Welcome friends to the lecture series of the course Marketing Research and Analysis. Today we will be discussing about the hypothesis testing on a different setup when the researcher is facing a condition of of more than two groups. So, first of all let us understand what do we mean by two groups and how do we test a hypothesis in such a condition. So, in one of the lectures when we were talking about experimental design, if you remember we were talking about that in experimental design there are basically various kinds of designs, among which you studied something called statistical design, right. So, what is the statistical design? So, we talked about statistical design, right. So, under statistical design we talked about the randomized design, right. So, a randomized block design, and then we talked about the Latin square design, right, and then we talked about something called a factorial design, right. So, in this these experimental designs are helpful when the researcher wants to know the effect of an independent variable on some of the dependent variable, right. So, statistical designs are very helpful, especially in the case of factorial design. It helps you to understand the effects of two or more variables, independent variables, on the dependent variable along with the interaction effects, right. That means what? A has an effect on, let us say, D, B also has an effect on D, and A and B together also have an effect on D. So, these are called the main effects and this is called my interaction effect. So, let us understand a situation. For example, let us say the presence, let us say a particular kind of chemical, right, or when you produce a particular kind of chemical, it has to be produced at a particular temperature and pressure, right. So, temperature has an effect on the, let us say, the final production of the material, and pressure also has a direct effect on the material, and temperature and pressure together have an effect on the final outcome or the final material. So, these effects are you cannot find out in other in generally. So, in such a study we use a this kind of experimental design we talk about is called a factorial design, which is a very easy and a very better method, so that you can compare two groups or more and you can see the interaction effects in that. So, let us understand. So, how do we test this hypothesis and what are the basic requirements to go for it? So, the first is called analysis of variance and analysis of covariance. So, what does this analysis of variance and covariance mean? These are the techniques which are used for examining the differences in the mean values of the dependent variable associated with the effect of the independent variables. That means, the change in the dependent variable with a change in the independent variables is what we are trying to find out. So, if there are two groups, for example, let us say if there are two groups, group 1 and group 2, then we use a generally we test a hypothesis or two levels or two groups, whatever you understand, two levels also you can understand. So, with two levels we can say, let us say, high income and low income, right. So, the effect of income, high income and low income on, let us say, the tax paying process or the taxpayers honesty, let us say how honest is the taxpayer and how income affects it. So, we have taken two groups of people, let us say high and low, and we are trying to check whether this has got an effect, right. So, when we are having two groups only, so in such a condition we can test it to a simple t test, right. But then if I introduce a third group called the middle group or the middle income group, then I have three groups now. So, when I have three groups, I have only a choice that I can do multiple t tests between high and medium, high and low, and medium and low. So, three tests I can do. So, there is a problem. So, this problem is actually because if you do multiple t tests, then what happens is the type 1 error gets inflated, right, because every time you take a 5% significance level. So, each time with each test, so 5%, 5%, 5%, the test becomes more inflated, the the significance level, and the type 1 error gets increased, right. This reduces the power of the test, this reduces the power of the test. So, in such conditions analysis of variance is the technique which is to be used. So, today we will be dealing with this analysis of variance, and I will try to explain how it is used for the test of hypothesis. So, what it says here, a statistical technique for examining the differences among means for two or more populations. So, here we have taken the high income, low income and the middle income. The null hypothesis is that all means are equal, right. For example, suppose that the researcher is interested in examining whether heavy users, medium users and light users and non users of yogurt. So, that means there are 4 kinds of users, somebody who consumes a lot of yogurt, somebody medium user, somebody light user and somebody who does not use at all. And is there any difference in their preference for the yogurt brand, because there are several brands of yogurt. So, do these users have a different taste of brand according, and does it depend on their usage? So, it is measured on, let us say, a 9-point Likert scale. So, you know what is a Likert scale? So, it is an itemized scale where we are trying to study where each value has got some has some reference, right. So, what it is saying, the null hypothesis is that the 4 groups these 4 groups were not different in having a preference for the XYZ brand and it could be tested using ANOVA. So, how does it look like? So, let us say you have taken the score in a 1 to 9 scale. So, let us say I am having 4 groups. So, how I can make the table, for example. So, I have 1, 2, 3, 4, these are the 4 groups. So, what has the group 1 given a score? Let us say 3, group score 4, group 3 let us say 2, group 4 5. So, these scores that I am giving, these are the scores, right, and these are the brands. So, if you see not the brands, the users, sorry, these are the users. So, 4 types of users. So, I am saying, so particular yogurt brand they have taken XYZ, and what score are these 4 groups of people, 4 users giving to this for this brand. Now, let us understand this. What in the simplest form, it says ANOVA must have one dependent variable. Now, what is the dependent variable in this case? That the taste or the preference for the yogurt brand. So, the preference is the dependent variable, right, and it is metric in nature. That means what? It has to be measured in a interval or ratio scale. So, a metric scale or a continuous scale, it can be measured in an interval or a ratio, right. Now, this is one thing. Second thing is, there must be one or more independent variables. Now, what it says is, basically when you want to see the effect of the on the dependent variable, so you have to have some independent variables. So, at least you should have one independent variable, or you could have more than one independent variable. So, if you have one independent variable, we say it is a one way ANOVA, right, but if you have more than one independent variable, then we say it is a n way ANOVA, 2 way, 3 way, n way ANOVA, right. So, the independent variables must be all categorical. Now, in this case, how many groups do we have? We have 4. Now, the heavy users, the middle light users, the no users, something we had, right. So, heavy, medium, light and non users, right. Okay. So, categorical independent variables are also called factors. So, that is what I was saying. So, the categorical independent variables are also called factors. So, how many factors do you have? Let us say in this case, user is, you are only checking the user, right, users interest. So, they may be, it is only then, because it is only one thing that you are testing, that is the users effect on the brand. So, the kind of users effect on the brand, it is called a, only one factor is there which has 4 levels. So, one factor 4 levels. So, that is why it is called a one way ANOVA. Had it been, let us say, the user, the type of user and along with the income of the user we would have taken, right. Then in that case we were trying to check not only the type of users effect on the brand's preference, but also the income, what income group he comes from, that also affects the preference for a particular brand. In that case, this would not have been a one factor ANOVA, but it would have been a, let us say, a two way ANOVA, because there are 2 factors, one the user, the other is the income, right. Okay. A particular combination of factor levels or categories is called a treatment. So, treatment is that what we are trying to check, what is the effect of the treatment. So, when we give a treatment, if you remember when we did our experimental design, the whole thing about experimental design is about when you give a treatment to the variable, what is the change in the dependent variable. For example, let us say we are trying to take a bunch of students and trying to see whether a new method of teaching, maybe through let us say some online mechanism or some kind of a new test that has emerged, let us say, or some or it maybe the teaching done outside, maybe in a garden. So, if you teach students in a garden, does it have an effect? So, when we are trying to see, so this is a treatment we are giving. What happens if we do not make any changes? So, then it is a controlled group. But if we make a change, so what is the change? The change is that you are now removing the students from the classroom and you are taking to the outside into the open air and you are trying to teach them. So, does this change have an effect on the students' ability to score? Now, this is called a treatment. So, when you are giving a treatment is, for example, again if you want to understand, like when the farmer treats his soil with some fertilizer. So, what is the effect of this fertilizer? So, that is the treatment effect. Okay. So, hypothesis of a one way ANOVA is that the null hypothesis is that in this case there are 4, or let us say there are infinite, then mu 1 is equal to mu 2 is equal to mu 3 is equal to goes on infinite. So, the mean among all the levels, there is no difference in the mean among among the levels of the factor, right. So, all population means are equal, we are saying there is no difference. So, that is the null hypothesis, that is no treatment effect. That means the treatment, suppose the farmer in this case, let us say this is the farmer has a small patch of land, right. Now, he breaks it up into 4 patches, 1, 2, 3, 4. So, now he is trying to put a fertilizer here and let us say here, and he tries to keep this as it is, right. Now, he wants to see whether the yield or the output that he derives from these 2 places and the output that he derives from these 2 places where fertilizer is used, is there any difference or not. Now, when he tries to do this study, so he says whether if there is no difference, then the treatment effect is not there. But if suppose here the yield increases or decreases, whatever, then he can predict, or he can say that because of the fertilizer the yield has changed. That means the treatment, which is the fertilizer which I am giving in this case, has got an effect on the final output, which is the yield. Okay. What is the alternate hypothesis? Not all of the population means are the same. So, at least one population mean is different. That means if I am taking, let us say if I would have divided into this into 4 different patches, right, and I would have put the fertilizers, right. So, I am trying to see whether the fertilizer has got any effect or not. Now, suppose I take the output from 4 different patches, 1, 2, 3, 4, right. Now, then I would say, let us say there are 4 kind of fertilizers now I am using in this case, fertilizer A, fertilizer B, fertilizer C, fertilizer D. Now, I am trying to see the effect of fertilizer on the output. So, my mean is, my first null hypothesis is that the yield or the output that you derive by using fertilizer A is equal to the yield from fertilizer B is equal to the yield from fertilizer C is equal to the yield from fertilizer D. That means that the effect of the fertilizers is not there, all the fertilizers are giving the same output, right. So, that is what it was saying, there was no treatment effect. But as a researcher you do not want to do that, you want actually to see that there is a difference. So, if there is a difference, what is the difference, which is one of them is giving the best yield or the poorest yield. So, at least one population mean is different. So, that means in this case mu A, mu B, mu C in this case and mu D, at least one of them should not be equal, at least, right, at least, or whichever that, and that one which one you want to keep is up to the researcher, but he wants that at least one of them should be different. Then there is a treatment effect, then we can say, well, the kind of fertilizer has an effect. It does not mean that all population means are different, some pairs may have the same, may be the same. That means maybe in this case let us say mu c, that means C and D are giving the same result, or even they may be equal to A also and only B is different, or A and B are different, C and D are same, right, it could be anything. So, one way analysis of variance involves only one categorical variable. What it says? Only one categorical variable or factor with several levels, right, it should with several levels, right. The differences in preference of heavy users, medium users, light users and non users would be examined by this one way ANOVA. In this, a treatment is the same as a factor level. So, in this case how many in this fertilizer case what we said, there are 4, right, A, B, C and D. So, there are 4 levels we are saying, right, and we are trying to say that each has been given a different treatment, a different kind of fertilizer, right. Now, so we want to check the effect of this on whether the levels they are giving the same result or they are giving a different result. Okay. Now, what is the n way analysis of variance? I explained, if 2 or more factors, for example, now fertilizer you have taken, right, in the last case. Now, you want to take also along with the fertilizer you want to see the usage of technology. Let us say whether the farmer is using just bullock, right, or it is using some kind of a tractor, right. So, what is he using? So, the kind of technology being used also will have an impact on the yield. So, this is the fertilizer, this is first factor and this is the second factor. The second factor says that the kind of technology being used, right, that will also have an effect on my dependent variable. So, now in this condition there are 2 things now the researcher is going to check, fertilizer and technology. So, in this case since there are 2 factors we say it is a 2-way ANOVA, right. Now, suppose you would have used the third case, fertilizer, technology and the seeds, right. Now, he says the seeds are available from various brands, let us say now high quality, low quality or medium quality. Now, when I am using this third factor, so the kind of seed, then I am saying it is a 3-way ANOVA. So, similarly you can go on increasing the number of factors and that is why you term it as a n way. So, n stands for 1, 2, 3 whatever number of factors. Okay. If in addition to product use, the researcher also wanted to examine the preference for XYZ brand of customers who are loyal, in this case you see that example. Now, along with the preference of the yogurt brand, in addition to the product usage means heavy, light, medium, that one. If along with this he is also interested to see the loyalty of the customer, right. In this way a n-way ANOVA could be conducted, or that is in this particular case it is a 2-way ANOVA, right. Now, what is this analysis of covariance? Now, many times people get they get confused and they get complexed, they get scared ki well what is this? It is very simple actually. Analysis of variance and covariance are more or less the same, except that there is only one difference. What is the difference? You see, it says if the set of independent variables consists of both categorical and metric variables, that means the number of factors that you are using, right, the independent variables can be either both of them are categorical or one is categorical and the other is metric, right. Then this technique of analysis of covariance is used, right. That means what? Categorical variables we said, let us say categorical in that case was heavy user, medium user, light user, no user, right. And suppose you want to take another variable, let us say in that case the age. Now, age, somebody is let us say 30, somebody 40, somebody 20, somebody 50. So, when I am taking this age, this is a continuous variable. So, there in a measured in a ratio scale, that means, so in this condition we cannot use we do not use a ANOVA, we will use a analysis of covariance, right. An advanced ANOVA procedure in which the effects of one or more metric scaled extraneous variable are removed from the dependent variable before conducting the ANOVA. So, it says that you try to in simple, if you understand, that means there is one categorical variable and the other is a ratio scaled continuous variable which is both taken together, and we then find out the impact on the dependent variable. Okay. Example of analysis of covariance. It would be required if the researcher wanted to examine the preference of product use groups and loyalty groups, taking into account the respondents' attitude towards nutrition and the importance they attach to dairy products. Now, suppose you also measured what is the attitude of the respondents towards nutrition, how much value they gave to nutrition, right, and thus how much importance they attach to the dairy products. So, this is something you have measured maybe in a continuous scale, maybe in an interval scale in between 1 to 9, or the preference can be measured in several ways. So, but it is a continuous scale or a let us say a metric scale. The latter two variables would be measured on 9-point Likert scale. So, the Likert scale is a interval scale, please remember, Likert scale is a interval scale. In this case, the categorical independent variables, what are they? Product use and brand loyalty are still referred to as the factors, whereas the metric independent variable, which one? The metric independent is the attitude towards the nutrition, right, and importance to the dairy products, how much attachment they have for nutrition, how much value they give to nutrition, and how much do they love the dairy products, are referred to as covariates. So, this presence of a covariate actually is responsible for the development of the technique called analysis of covariance. So, a metric independent variable used in the ANCOVA, right. So, I think you are clear. So, in this case you have minimum one categorical independent variable and one metric independent variable. So, this presence of a metric and a categorical gives rise to the need of a ANCOVA technique. Now, let us understand the relationship between t-test, ANOVA and analysis of covariance and regression. So, these are all related. How they are related we will see. Now, if you see, when you want to measure the metric dependent variable, the dependent variable is metric, that means a continuous or something, right. So, and you have one independent variable, and that independent variable is in a form of, let us say, 2 levels, which is categorical, it is a male female, high income low income, right. So, when you take loyal not loyal measured as 1 and 0. So, when it is measured in a binary, right. So, when the independent variable is male or female, now I want to see the effect of or the impact of love for movies by male and female students. Now, how much do the male and female students have a love for movies? Now, love for movies is my dependent variable, and independent variable is whether it is a male or a female, the gender, right. So, in such condition we said we use a t-test. But when we have one or more independent variables, so now you have not one independent variable, earlier you had the gender, but now along with gender you have something else, right. So, when you have more than one independent variable, what happens is, suppose it is a categorical one, right, then you have analysis of variance. Suppose along with the you have more independent variables, but they are all categorical, then you have a 2-way ANOVA, 3-way ANOVA, whatever, right. But suppose it is a categorical and then an interval, the next one, then analysis of covariance. Suppose you have the independent variable measured in a interval scale or a continuous scale, then the technique is we use a regression. That means, y is my dependent variable in a continuous, right, measured in a metric, right, and x suppose is also independent variable is also measured in metric, then it is a case of a regression. Okay. Now, coming to analysis of variance, one factor, one way analysis of variance, more than one factor we have n way, right. Now, let us get into the one way ANOVA. So, some of the statistics associated with one way ANOVA, the first one is called eta square. Now, what is this eta square? The strength of the effect of x independent variables of x, there is an independent variable or factor on y, is measured by this eta square. The value of eta square varies between 0 and 1. So, it tells you the strength of the effect of x on y. So, how much is the strength of the independent variable on the dependent variable is measured by this term called eta square. F statistic, or we say F ratio, right, it is the null hypothesis that the category means are equal in the population is tested by an F statistic. What does it mean? So, if my F statistic is significant or not significant, then on basis of that I can say whether, on basis of this F ratio, I can say whether my means, that means the mu 1, mu 2, mu 3, mu 4 in that earlier case which we discussed, are either same or not same, at least one of them is different. If it is not significant, it is not significant, then we will say, well, there is some difference among the means. But if there is if it is let us say, so the F statistic says if there is a significant difference, if the F statistic is significant, that means there is some difference among the means of the population, right. But if there is, it is not significant, that means we cannot say that there is a difference and we would accept the null hypothesis, right. Mean square, this is another term that is used, is a sum of squares divided by the degrees of freedom. Now, what it is I will slowly explain, right. Another term is sum of square between. Now, there are two things in this when we talk about the ANOVA. So, let us say there is a group 1, there is a group 2, there is a group 3, right. So, what is the difference in the sum of squares, that means the among the values in the corresponding groups is called my sum of square between the groups, right. Now, what is the sum of square within? The sum of square is within is the maybe the the variables within. So, the difference or the difference in the sum of squares within these variables within the group is called my sum of square within, and is denoted as sum of square error also, right. This is the variation in y due to the variation within each of the categories of x, and this variation is not accounted for by x. That means, it is not accounted by the independent variable, it is just within, it happens within the variables inside the independent variable. And similarly, sum of square of y, that means the overall, the total sum of square within of each value, if each cell from the cell value from the mean from the overall mean is called my sum of square of error. So, these three things are very important before we understand and we go deep into the analysis of variance. So, just I hope you have understood today that analysis of variance is a technique which is or analysis of covariance for that, when you have more than one independent variable, and these independent variables are measured either in a categorical or a categorical plus non-categorical or a continuous method. So, in this case, if it is both categorical or the independent variables are measured in categorical, then we would say it is a analysis of variance test. But if the independent variable is one is in categorical and the other is in non-categorical, then we use a technique called ANCOVA. So, now we are continuing with the the analysis of variance technique, and in the next lecture we will solve some problems and go understand little deep how do you solve such a problem when you face it, right, in the real life. So, thank you for today, we will meet in the next class.